Okay, isotopes. Isotopes haragadi karino haibani akhoi hana angar oidu sudum tame class 10 dasu ko. Now isotopes haragadi same element gi atom sing ko. Karigumba moida different mass leraba. Same element haragadi akoina khangadab se same atomic number legadamni. Element amagi atomic number haibase amakhaktani. Yare ko. Aduga atomic mass ti tongan na leraba. Yare ko. Atoms of same element, if they have same atomic number and different masses or mass numbers, then that atoms are called isotopes. Isotopes haina kaugani ko. For example, today yengasi akoina chlorine haibase magi atomic number 17 ni. Yare ko. So they represent the ripsu ko. For example, isotopes of chlorine di yango makhala chlorine da isotope ani lay chlorine 35 hamga chlorine 37 hamga. Haibadi atomic mass 35 or mass number 35 leibonga adu 37 leibonga. Yare ko. Adu chlorine gi atomic number di still animax dedum 17 oy. Yare ko. Aduna hariba sigi chlorine hariba atom sing se chlorine ge atom sing se different mass leiba amana 35 lei atopa chlorine madana 37 lei, but they have the same atomic number, so such type of atoms of the same element are called isotopes. Similarly, there are other examples also. For example, isotopes of hydrogen. Isotopes of hydrogen. Isotopes of hydrogen say kya lege hai matamda ahum leiba ko. 3 isotopes lay. 3 isotopes. What are they? Number 1, normally hydrogen haina sudum kawi yare ko hydrogen or protium haina su kawi yare ko maming se protium haina su kawi adu sigi protium haiba se karamba hydrogen buno hai matamda the one which has atomic mass or mass number 1 level yare ko atomic number di still adum 1 lerani, then aduga magi mass number se 1 lero aduga dugum hydrogen do koina protium natraga dum hydrogen haina su koina dum ko weba ko. Second deuterium haibam lere deuterium yare ko sisna karam bano hai matam dama su it is represented by capital D na represent wi ko aduga capital D sina sai natraga height stadum represent or sukai de adu bokon capital D na represent hek doi deuterium haibasina magi atomic number still adum 1 oigani aduga magi atomic mass na or mass number sina akoina 2 haina lay yare ko aduga ahum suba isotope of hydrogen sina kanano hai matamda tritium haibam lay tritium hairagadi atomic mass number or atomic mass or mass number say 3 label. It is represented by capital D T and it has atomic number 1 and aduga atomic mass na or mass number na 3 label. Then it is called tritium. So these are the isotopes of hydrogen. Then next next is isobar. Mathangda isobar haibam lere. So what are isobars? Isobars are gonna kari no sinebuko. The isobars are atoms of different elements having same mass number but different atomic numbers. Isobars na hari kari no. Hai yeng siko. Isobar na hai se element tongan wagi atom sing oigadabani hamni. Aduga moigi same mass number di leba aduga atomic number na different legida. If atoms of different elements have different atomic numbers but same mass number leraba adugumba atom sing do kone kai kaune ba isobars kauni habni. for example sida yengsi argon haibam lere, then potassium, then calcium hariba sigi ahum se akoina mathakta tapiba singchibuni ko koina mass number natraga atomic mass haribase adugo makhada subscript oina hapiba number singchina koina atomic number haina ko yare ko adu makhada leiba atomic number singse different elements oimnina akoina khangadabse akogi mind legadabse ko element amagi particular atomic number amakhaktam leganiba element amagi kaidonungde atomic number ani leiro because akoina hana anga tamakibido atomic number is the fundamental properties of all the elements. Yareko. Element singimagi chemical properties or vi, then physical properties or vi si singsi kanana pirak to know ham the atomic number na pirak to you. Yareko class 10 to rokibodo. Adu yo akoinozi yendu say elements to one to alagadi atomic number di different or any have some kangin. But mass number manarmaba. Aduragadi mass number hek manarma matamda adugumba element singe atom singdo akoina kari kaudriba isobars haina koi. Yareko. Yengba matamde yo mathakta tapiba singsina atomic mass or mass number ni haire makhada subscript oina yawriba number singsina akoina atomic number ni haina haire. Aduri makhada lairiba atomic number sing argon gi 18, then potassium gi 19, then calcium gi atomic number 20 ni. So the atomic number of these argon, then potassium and calcium are different, but they have the same atomic mass or mass number, that is 40. So these atoms of different elements are called isobars. Correct? Sumain tawdana akoida atopa isobars mayam su leigani ba ina example amani khakta pibani ko adu sumain taw khandokani habani adu haying exam point of view da dika main laktuna matamda makhada option khara piraga have option sing karamana isobar no karamana isobar natabano khandu kaina hangakada mathaki isotopes ta ki dugi su chamani option mari pire option mari sing manungda isobars nataba chemical species sing kana kana no khandu kaina ko adu kona lakhe se hojikiri basic te khara chakhe se ko so isobars are the atoms of different elements having same mass number but different atomic number right ko dugo next amu yengasi mathang koina isotones haibam leire. So what are isotones? Isotones haigadi karino. Ko isotones haibasi yengasi koina. Dudi isotones haigadi atom singni moisu for example carbon, nitrogen, oxygen. Ahum chilo se ko moi ge atom sing je carbon ge atomic number 6 lay, nitrogen in a 7 lay, aduga oxygen in atomic number 8 lay. Correct. Mass number na carbon gi 14, nitrogen in a 15, then oxygen in a 16. So number of neutrons present in the carbon se kya no hani yeng se ko. Correct. So this is the note haina mahapam ge. Note we know that mass number have se kariga mana ge hai matam the number of protons represented by small p ka small p ne represent hoy plus number of neutrons. And it is represented by small a ne represent hoy. Aduragadi mass number have se kaiga mane heba number of protons plus number of neutrons ka mane hebani. So from this akoina hojik the we are ise karino ha matam da koina pamri number of neutrons puthopam pambani. So number of that is ka that is hagera or hagera pamama ka that is number of neutrons is equal to mass number minus arrange tꯧthosiko aduga number of neutrons se puthokpa manina number of protons equal to gi wangra thangrasi aduragadi minus la ani minus number of protons yare ko number of protons sibune koina number of neutrons puthokadabagi relative mari leinaba magi formula se ko so akoina hujik pamidi kari puthokpano number of neutrons of carbon puthokpani but we know that for carbon the atomic number represented by capital Z is equal to 6 and the mass number is represented by capital A and its value is 14 yare ko magi value na 14 ne so from this akoina kari khange hamatam dane but we also know that sida topa maga hapake ko formula ma but we also know that capital Z yare ko capital Z atomic number have a kari ga sumana ge hamatam da number of protons masinga sumani samna p hani rage ko and again it is also equal to number of electrons present in an isolated atom amade yauba number of proton masinga number of electron masinga and atomic number ga mani yare ko aduna but we know that the atomic number of carbon is 6 yare ko atomic number of carbon se 6 ne haiba se koi khangi yare ko so from this we know that number of protons p is equal to should be small p is equal to 6 yare ko so akoina ju puthokpa pamidi karino number of carbons carbon se de orba mass number of neutrons puthokpa pamani then number of neutrons small n is equal to aisida short form do lo iramage ko waina ba n represent we hai ke how hero how hero
carbon ki atomic mass is 12 metro
okay
14 nitrogen ki
isotopes name ase carbon ga isotope mani carbon da carbon 12 carbon 13 and carbon 14 leiba ko yaraba isotopes akoi mathak ta tawkre dana ko isotopes the carbon gi mass ahum lei 12 leiba ma then 13 leiba ma and 14 leiba so akoi no hojik 12 leiba duga di akoi number of neutron masing mana roiba ko aduna ma isotones na team akoi no hojik tawrise isotones ne ba ko so isotones o hena na carbon gi isotope 14 mass number leiba so in low ne ba ko yaraba there are three isotopes of carbon carbon 12 carbon 13 and carbon 14 among them we choose carbon 14 yare ko carbon 14 ne ko is the low ribs 12 low ya de have the late ko 12 flower di nitrogen ga oxygen ga moi hom se punna isotopes sorry isotones oero yare ko sigi ahum se isotones ni haibani isotones adudi if moi se isotones ne haire kari managadab no they should have the same number of neutrons yare ko aduna carbon 12 lorgid ai hariba isotones se tar oidini yare ko adugi da mukta khoina kaidorino hai matam dane sigi carbon 14 join lobuni so carbon 14 da koi number of neutrons se kaya yawbunu yengsi ko adu sigi asang mase aina sumaini iraki ko amuka there is saraga kitang samjalake koina budi re ko nogi khangna na bagi ni sije there is sigi formula singjina to an igidomni ko there is number of neutrons small n is equal to mass number have so koina kari na represent to gam tam da capital A na represent to ko yare ko so number of neutrons small n is equal to capital A mass number minus number of protons t small p na represent to ko so sigi formula sima ya maru e khoi khangjing gadawni ko derivative ngakni number 1 thariba sigi sibu khangagadi ko sigi number 1 thariba se sibu khangagadi loin derive tor khoi puthok ya ngakni yare ko aduga number 2 sisu adum maru oi because sidagi ngakni ko on thon jin tor loi semak ti ba mayam se ko aduna we know that atomic number of carbon is 6, but we know that number of protons in an isolated atom is equal to the atomic number of that element. So number of protons in carbon is also 6. Then neutron masing dikra mai puthok no, we know that number of neutrons is equal to atomic mass number minus number of protons. But for carbon the mass number is 14 and number of proton is 6, which is again equal to kya ka mana ni dude 8 ka mana ni ko. Similarly we can calculate the number of neutrons present in the above two specimen, that is nitrogen and oxygen. Nitrogen is to oxygen is to puthok ya ni ko. Aduragadi we know that the atomic number of nitrogen is 7 and that of uh, uh, the atomic number of nitrogen is 7 and mass number is 15. So atomic number dige koi kari khangani number of proton masing khangani. Then number of neutron masing puthok ke harabadi number of neutrons puthok ke harabadi 15 minus 7 kya tara still 8 tai ko. Then number of neutrons se nitrogen ga carbon ga ani se manaramani. Similarly, amuksu makoin oxygen the yauba number of neutron masing puthok pa yagani. Kamai puthok tiba atomic mass or mass number dagi number of protons natraga atomic number do khaidokra lore. Adu sida sudum 16 minus 8 yareko. That is 8 adum tai. Yareko. From this we can conclude that these three atoms of different elements carbon, nitrogen and oxygen are isotones because they contain 8 neutrons in their respective atoms. Mogi respective atoms in the carbon 14, nitrogen 15 and oxygen 16 have 8 neutrons in each atoms. So they are isotones. Similarly, haying noida atopa example mayam pirak pi no the question da hang pi ko xyz any xyz ko element ahum loroga mogi number khara pirak pi atomic mass then number of protons khara pisalaga noida high river species sing xyz high river species sing se isotones la isotopes la then isobara khandu kind hang pi finally aroibada akoin hojik yeng du se isoelectronics saibam le so now isoelectronics isoelectronics hai kari no yengs iso means equal habani ko electronics means electron degi lakoni adu kari gumba species singuda chemical species singuda any chemical species pyramid khalo ani natrag ani degi henna ko hairi pyramid liba chemical species singdu dei da number of electrons chap manarab if they contain same number of electrons then such species are called isoelectronics. For example yengsi sigim iron ga neon ga sing acting tham gisi ko sodium ga magnesium ga ani sing sodium ion and magnesium ion ani sing. Now sodium ion there ko step 4 and apam again 4 sodium ion 4 sodium we know that kitang sang ni rake ko force e jesu ya dia jani sodium de ana dum horge ko sodium ion sit no tum tos for sodium capital Z ko capital Z is equal to kya no mage sodium ge atomic number of sodium kya hoy 11 ko yare ko adu gadi mangon de yoba number of electron masing de kya hoy gani represented by small e ko number of electrons se small e na represent hoy na khalas kya hoy ne dudi 11 still hoy ne yare ko aduga now for sodium ion ko sodium ion lor si adudi sodium ion sida charge kya no kari bese khoida +1 kai ko that means electron ke hante hai no masing je ama hante hai bani so hane isolated sodium normal atom sodium atom dadi 11 electrons yarom bani yare ko but now ama handagra di number of electrons se kya hoirani 10 hoirani yare ko sigi the yori sodium ion the yori charge ni tai be se kari no hamatam da positive charge karam agadi there is lack of electron having yare ko electron hanthe bani magi isolated system the isolated atom ama the yauba number of electrons to the positive charge le yaur madi magi ion da adugi masing do hanthe bani electron so positive ama khak le bani na sidai da koina electron ama hanthe na kan gani so for the sodium ion we have 10 electrons which is one electron is leg electron ama hantagani decrease from the sodium normal atom similarly koina magnesium gi su puthok ya roidra for magnesium normal magnesium gi magi atomic number kya no Z is equal to 12 so from this we know that number of electron is equal to kya ho raha 12 ho raha ko but akoina pamini kari gino sodium ion gi number of electrons pamna tra but for sorry magnesium ion have ko but for magnesium ion ko magnesium ion gi yengasi but for magnesium ion the charge on the magnesium ion se kya no what is the charge on the magnesium ion 2 plus like ko that means electron kya leg sat kani hai no 2 chat kani have adu the number of electrons in the magnesium ion se kya ho raha ni 10 ho raha ko yare ko so these two species sodium ion and magnesium ion yare ko sodium ion siga then magnesium ion ani se they have the same number of electrons so they are called isoelectronics similarly fluorine gisu 10 fluorine ion gisu 10 electrons lerangani neon gisu 10 electrons lerangani sidadi fluorine gidi negative charge kai have na trasida fluorine anion ne same use adu gidi electron amma helakaduni but we know that the atomic number of fluorine is kya no 9 so 9 plus 1 minus sama carbon in electron hele have ne ko charge se negative oiragadi number of electrons se increase tauki have ne so amaka increase the only because there is one negative charge so fluorine ge atomic number the 9 like na number of electrons 9 oirani then with this charge we get 10 electrons could 10 electrons lay fluorine ion the ko similarly neon ge atomic number 10 ni aduna maram oraga magi number of electrons su 10 oigani. So all these species, sodium ion, magnesium ion, then fluoride ion, or it may be fluorine ion harasu kesu dikai ko fluoride haigira ko, and neon sigi haribi species mari se they are isoelectronics to each other because they contain same number of electrons. Same number of electrons yawe aduna haribi sigi species sing se isoelectronics ni haniko. So ko hijik tamisi kaino isotopes, isobar, isotones, and isoelectronics mari tami makal mari ko adu sigi chemical species mari se yamna hangan ba jaga ni sai sisu noina prepare to matam na munni yeng mum changi definition jina ki akoin hijik tamisi atomic model ni yare ko atomic model atom singi structure ji karmai to buno halu tamani adai ahan bada J.J. Thomson's model tawgre failure oigre next second da koina Rutherford model tawgre Rutherford model da atom ama haibase mayai da nucleus lay akoi budana electron lay haina tamgre ko mayai da positive charge ni madu nucleus koi akoi budana electron lay negative charge carry tawi adu electron sing na chatpado akoina orbit ni hana high grade circular path chatli na ko adu hariba atomic model se amu magi su drawback lay re matam ni matungina science na sum chokla pi matungina ko so among those drawbacks khara ye se ko first ai sida picture mo lake sigi picture je ngasai Rutherford adi kai high ki ge hamatam ne electron sing se magi circular path adum revolve toroga chatli habni nucleus ki akoi bada around the nucleus the electrons are revolving yare ko adudi nupa ma thole Maxwell haiba nupa ma thole magi theory gi matungina kari harake matamne kari gumba charge puba particle amana sum circular part amda koina chatlagadi mangonda yoromba energy do mangkini habni yare ko amuka hange if charge puba substance amana circular part amna sum koina sum ungba matamda it will emit energy from its body ko magi masadu dagi energy thado kiniba energy thado agadi magi energy do hanthrakpe matugina mase sum mana koiram orbit se sigi size sum pixel akani adugo last kadai da tadiba nucleus ta tasin gini electron se charge pui so electron sina nucleus ke koi da chatle haibani hana so if with acceleration and a charged particle moves around the nucleus then the orbit or the radii of the orbit will become shrink sum pixel akani yare ko sum pixel akani du kadai ta du finally ma nucleus ta akani yare ko electron do nucleus ta sin gadi then haidiba atom do mangrani atom do later yare ko aduna Rutherford hairam se lali haina Maxwell gi theory gi matungina tholi yare ko Maxwell na kari haige hamatam da husike na bado if a charged particle moves according to electromagnetic theory of Maxwell a charged particle undergoing acceleration should emit electromagnetic radiations having radiation natraga yam samna energy haise ko energy thadorakani energy thadogadi magi orbit to sum pixel ani yare ko sum pixel kan finally ma se nucleus ta singrani electron habse charge pubani so with acceleration man chatpa matam sum magi energy sum thadorokpana marmarga radiation sum thadokina marmar kanda finally ma se nucleus ta tare then electron do stable oidre electron mangrani ko so this is one of the drawback of Rutherford ki drawback amani second drawback amu yengsi second drawback to kai hare could not explain the stability of atom gi stability se atom amu oibagi hosiki mathakta haigi bodu yong ko asai electrons gi sum revolve to pixel edu ko finally nucleus ta taraga atoms to mangi habani adu karigi mangde adum leidana ko mangi worgde akoi ga loi mangam dini ko oxygen leiriba degi leiriba elements ko loi mangi dana prithvi dana tra universe de poram ta leira maroi adu still leiriba se karigi leiriba no karigi stable oiraga atom se atom oina dum leibno atom hai on tamna koi element particular element am khakta gi natiko different elements all the elements ki atom sing do stable oiraga dum leibo adu kari maram gi stable oribno haibu di mana explain term de just atom haiba se sini lei khakta ni mana hairamis karigi adum leiribno stable oiraga mangribno haibis ni mana explain to bongom de yare ko then third point this model that means Rutherford model se ko does not give information about how electrons are distributed around the nucleus and what are the energies of these electrons. aduga Rutherford ki model sina ngasai man di hairam se nucleus na mayai de legani aduga akoi with the electrons sing sina ku revolve toroga legani haibani but mane adu khakte na hairam se tobotabu electron sing se nucleus ta ki kayam lap distance ta revolve toroga legadoribino kayam nak na legadoribino adu electron amagi charge na kaya no haibs di mana hairam di yare ko amukan ge Rutherford model na hairam ise magi model du na hairam ise kari neba nucleus sina atom amagi mayai da legani yare ko adugi nucleus ki akoi wada electron sing sina revolve togani hana hairam mani but he could not explain how the electrons are distributed around the nucleus how far the electron was from the nucleus te kyam lamna ma revolve toroga leibno magi radius se kaya no electron mem yaudri de ko atom sing de ko suppose oxygen the electron normal oxygen isolated atom amada yaudri number of kariba kay hebno hero kay hebno hero tadre okay makha chatra siko de ko so next the electromagnetic wave so what are electromagnetic waves electromagnetic wave aragadi kari no yengsi ko electromagnetic wave haragadi mangonda component ani yaugani electric habanga magnetic have component ani yaugani electric field and magnetic field hariba electric and magnetic field say they will perpendicular to each other yare ko the yengsi ko sig diagrams to yengsi magnetic field na so this is the yellow light yellow color se ko aduga amasina electric field ni yare ko sige hariba electric and magnetic field se kaidoge hamatamda moisi source amadagi propagate torko matamda tholko matamda ne they will be mutually perpendicular to each other moise amaga perpendicular oinagani if in a wave the electric and the magnetic fields are oscillating perpendicular to each other and again mutually perpendicular to the direction of propagation then such type of waves are called electromagnetic wave maming masada su yaw lere ko electro means electric field electric then magnetic field ani maksi pulap sige electromagnetic haps the so electromagnetic wave component in yawgani electric field habunga magnetic field habunga haidiba electromagnetic field se perpendicular oinaraba mabanik se ko aduragadi adugumba wave to akoina electromagnetic field haina ko guni yare ko okay then the characteristics of the electromagnetic wave electromagnetic wave ki characteristic properties kari kari leibano yengsi first is frequency frequency so what is frequency frequency haragadi kari no sine ko but frequency lactring ko iste kaino mi yengam si ko the wavelength haibam lere it is represented by lambda yare ko sigi symbol se lambda haina ko yare ko adugadi wavelength haragadi kari no sine wavelength ama haiba se kari no hamatam da koina wave si mathak to picture ma lere wave represent over picture ma lere ko so this is the mayai da sangna chingiba lines na koina direction of propagation or sometimes mean su kawi sigi mean sidagi highest point da leiba sibuna koina crest haina kore aduga mean sidagi lowest point da leiba point sibuna koina trough haina kawi yare ko Hanangar the system avani mean position sidagi or direction of propagation sidagi koina highest point low matam the sigi maton jure ko sibuna koina crash hana kore aduga mean position sidagi lowest depth sibo low matam da lowest depth point sibo koina trough hana kore are ko adu thangnaba crash ani or thangnaba trough ani se as a sin oinaba trough ani se sigi length sibo koina kari ko ge matam da wavelength hana ko amukan ge ko wavelength haragadi thangnaba crash anigi length natraga thangnaba trough anigi length sibo koina wavelength haina ko adu magi SI unit se it is expressed in terms of meters the phongdo wavelength gi SI unit is expressed in terms of meters there ko aduga next frequency habam lere mathaki se ko frequency se it is represented by nu there ko sometimes bihin is represented we are ko sidale ibu symbol sidin nu ko ko there ko nu na represent we the frequency hagdi karino sine example oina ma harake nang si bus train amada lepe khalo nang lepiwa point se sida nang imangda bus cam yamna apiwa matam amagi manungda bus cam yamna masing cam yam bus na mamang sida thauruga chatkhige haiba number of bus to adudu bo koina frequency hena ko yam samna ko ji electromagnetic wave to laktuni natra so then karigumba point amada second amagi manungda ko point amase second amagi manungda wave kaya na power ga chapano the number of waves that pass at a given point in 1 second second amagi manungda wave kaya power ga chakki ge haibado point ama se ko adugi number of waves to bokoina kari ko ge matam da frequency hana ko and it is expressed in terms of hertz the expressed way natraga per second haina akoina expressed way ko so from this akoina ke doge ha matam da mu yare ko mu hai base kari ga mana ge matam frequency hai base ko frequency mu is equal to 1 by time or 1 by s ko sibuni ko na frequency hai base yare ko okay next amok velocity so what is velocity hai base kari no velocity haragadi second amagi manungda wave amana kaham yamna distance cover toge habdo kaham yam sangna chatke habdo the distance traveled by a wave in 1 second wave amakakna second amagi manungda kaham yam distance cover toge habdo adubo koina kari ko velocity hana ko then it is represented by c yare ko c na represent wi but magi character malai velocity ge ko velocity of electromagnetic radiation se ma se radiation se they all travel in an equal speed that with that of light na travel to speed se siga chamana na ziki electromagnetic radiation sing sichu travel to so what is the speed of light se kya na
3 into 10 to the power 8.
3 into 10 to the power
8.
8 asikhak to bra
Something.
unity
Unit meter kilometer mudin
bosnika kya hoy prithoy bhi भाभी नहीं क्या हुआ
3 into 10 to the power 8 meter second. Meter second inverse.
meter second inverse hagira natraga meter per second hagira ko isu kai meter per second mani gira or meter second inverse ꯌꯥꯔꯦꯀꯣ ꯁꯤꯕꯨꯅꯦꯕ ꯑꯩꯈꯣꯏꯅ speed of light ꯍꯥꯏꯔꯤꯕꯁꯦ ꯌꯥꯔꯦꯀꯣ ꯑꯗꯨꯅ ꯍꯥꯏꯔꯤꯕ electromagnetic radiation ꯁꯤꯡꯁꯤꯁꯨ ꯁꯤꯒꯤ speedꯁꯤꯒ ꯆꯞ ꯃꯥꯟꯅꯅ travel ꯇꯧꯏ ꯌꯥꯔꯦꯀꯣ then next the amplitude ꯍꯥꯏꯕ ꯑꯃ ꯂꯩꯔꯦ what is amplitude ꯑꯗꯨꯗꯤ amplitude ꯍꯥꯏꯕꯁꯤ ꯀꯔꯤꯅꯣ it is represented by small a ꯅ represent ꯇꯧꯋꯦꯕꯀꯣ ꯑꯗꯨꯒ ꯃꯥꯁꯤꯅ ꯀꯔꯤꯅꯣ ꯍꯥꯏꯕ ꯃꯇꯝꯗ ꯉꯁꯥꯏꯒꯤ ꯑꯩꯈꯣꯏ ꯋꯦꯕꯇꯨꯗ ꯑꯃꯨꯛ ꯍꯜꯂꯛꯁꯤꯀꯣ ꯁꯤꯗ ꯁꯤꯒꯤ ꯃꯌꯦꯛ ꯁꯦꯡꯕ꯭ꯔꯥ ꯁꯤꯒꯤ ꯄꯤꯛꯆꯔꯁꯦ ꯈꯤꯇꯪ ꯋꯥꯠꯄ꯭ꯔꯥ ꯌꯦꯡꯉꯣ ꯁꯤꯗ ꯃꯌꯥꯏꯗ ꯆꯤꯡꯉꯤꯕ ꯂꯥꯏꯟꯁꯦ mean line or direction of propagation ꯍꯥꯏꯕꯅꯤꯀꯣ ꯁꯤꯗꯒꯤꯅ crest ꯐꯥꯎꯀꯤ ꯑꯋꯥꯡꯕꯁꯦ the height of the crest from the mean ꯁꯦ ꯁꯤꯕꯨ ꯑꯩꯈꯣꯏꯅ amplitude ꯍꯥꯏꯅ ꯀꯧꯏ or the depth of the trough from the mean position is called amplitude ꯌꯥꯔꯦꯀꯣ mean position ꯁꯤꯗꯒꯤ crest ꯑꯣꯏꯔꯒꯅ height ꯂꯧꯕ ꯑꯗꯒꯤ trough ꯑꯣꯏꯔꯒꯅ depth ꯁꯦ ꯁꯤꯕꯨ ꯑꯩꯈꯣꯏꯅ amplitude ꯍꯥꯏꯅ ꯌꯥꯝ ꯁꯝꯅ ꯀꯧꯏ ꯌꯥꯔꯦꯀꯣ so sigi amplitude sina kari taake hai matamdane light amase or radiation amase magi intensity or natraga brightness ta if akoina sigi diagram wave ki diagram si yeng matamda kari guma yamna sumaina konkhalaba ko magi height yam chawraba yam wangaba then intensity wange hagani yareko adugi light to yam brightness legani if magi curve se name or height name then intensity name hagani that means brightness low hagani yareko so amplitude determines the intensity or the brightness of the light to gi or radiation to gi magi intensity natraga brightness takani last akoina ama lere kari haba wave number haba lere it is represented by new bar wave number se new bar na represent tawi so it is the number of wavelength per centimeter yareko mase centimeter amagi manung da yawba number of wavelengths masingdo wave ngasai wavelength habde koi khangridana ko crest amadagi crest thangnaba crest am phoge asangbodo natraga trough amadagi adjacent trough am phoge asangbodo dubu wavelength ko kibino aduguma wavelength do centimeter amagi manung da kayam yamna yawge habdo the number of wavelength per centimeter is called wave number so it is the inverse of wavelength so mu bar is equal to 1 by lambda lambda se koina ngasai wavelength haina hagibdani ko so nu bar is equal to 1 by lambda so the formula am lere ko mathak ta su koi frequency gi formula am hakre then next relationship between frequency wavelength 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 and velocity hariba frequency wavelength and velocity ki marakta kari relationship leke habdo c is equal to nu into lambda ko sigi relationship so from this we can rearrange and get if we want to produce or if we want to calculate frequency of a radiation then after arranging we get nu is equal to c by lambda c by lambda haina phange again c se amuk akoina we know that lambda se kaya ga maneba in relation to wave number but we know that mu bar is equal to 1 by lambda ga mane have natra ko mathak to khoi to kibdo number of wavelengths wave number have the number of wavelengths per centimeter have on the nu bar is equal to 1 by lambda ha gidana ko anu sigi 1 keno se koina 1 by lambda se mu bar ga mane have ni na magi mahut substitute or se keno na mu bar na ko then adu ragadi koi phang se mu is equal to c edum leijare 1 by lambda layer then consider c into 1 by lambda have got man ko aduna 1 by lambda have moto koi kari hapsin bi are use mu bar hapsin bi are into mu bar ere ko so mind roga koina formula khara derived to we are so from these formulas we can calculate the values of the respective symbols sing sigi magi values sing putopyani for example makha question ami see now calculate the frequency and wave number of a yellow radiation having wavelength 240 nanometer wavelength 240 nanometer sangba radiation ama lere aduragadi magi frequency ga wave number ga putho habani yare ko aduragadi yamo sida solution da wavelength lambda here lambda is equal to 240 nanometer yare ko but we akoina wavelength se magi SI unit se kari ne hacking asai the SI unit of wavelength is meter ko aduna meter do on thok pam changeba so meter do on thok haradi 240 nanometers meter do on thok haradi 240 into 10 to the power minus 9 multiply to minus 9 meter yare ko 240 nanometer have se meter do on thok haradi number dum lejare 240 have am lejare nanometer ki mohta kai on thok pokhoina into 10 to the power minus 9 meter na multiply to yare ko then koin hojik pamadi kari hot pano frequency ne so frequency hot ke harabadi formula yengsi kari karamba formula panbe si ga homji manungda sigi formula se panbe ko piram libe sigi matungina we already know that the value of c is that is velocity ko velocity say 3.8 so high into 10 to the power yam sam sorry 2.98 adai de laiba ne ko samna khone 33 and low bani 3 into 10 to the power 8 meter per second or second inverse high given c की value से को and lambda की value से pyramid मान ना tra question zida we know that the value of lambda is 240 nanometer then we can calculate the value of frequency adu yong sida akoina pami se question se karamai formula se pandu no have se khandok pam changi karamai khandok tu na hana yeng se ko hot padi lai ni formula lai rom ni na ko mana kari wave number gi sing actung tham gi se calculate the frequency of yellow radiation have new so akoi gi hanan bo wakal faruk da se kari no ha matam ne frequency have se kari no have what is frequency hangam ni na akoi gi wakal di hanan instruct to godom ba idea se kari no ha matam da frequency is equal to what I was is equal to what yare ko kari no hangib jan khanglani khangdol matungda mana question si kari kari provide torongge kari kari piramge given the kari kari lege have sen yare ko given the huziki do lambda have dum pyramid tra yare ko sigi si wakal da khangadam ni ko then next lambda have piram bani lambda gi value yare ko si lambda gi value ni piram use okay then we also know that e si sing e der su ya ba ngak tani ko adu mathak ki si on thok ba simtang di iramo soidana ba heng ko exam da so c ki values de koi e der su ya re because we already know that c have a say c is equal to 3 into 10 to the power 8 meter per second yare ko c ki values de koi e der su ya ne so formula su lai re khoi da mu is equal to c by lambda have a formula am su lai re aduna formula si e dra phok yai adu for our convenience hauji ko indi e re ko value substitute tawro du regadi c ge value kya no 3 into 10 to the power 8 meter per second se hapchale yare ko divided by value of lambda d 240 into 10 to the power minus 9 meter ne yare ko adugadi sigi value se into 10 to the power atai tabro sigi value se tai ko very good second inverse second inverse haina igera natraga hertz haina igera ko kesu kaide second inverse second inverse haina igera or second inverse ki moto ko hais jet haina ibu ये को दो कोई convenience की नमक कई रसे बस second inverse नो मिले से ऐसा unit में बस को हाइन question द पिरम मरी मतुंगी नबरी खलो को hertz पिरम मरी hertz वनी इता रे करे को then लोरा bro नो
Sir,
oh haro
can you do not draw 1.25 lari 10 to the power 16 oidune?
1.25 ला दी 10 to the power 15 हो गया दबा करी को दिनो
16 oidune.
16
Hmm.
ओए रोय नंगी अहन भाई यो 3 divided by 240 दो 0.012 हाइन लांग वनी 3 divided by 240 से divide to मतलब ने 0.0125 है ताबरा
Oh, taduni shoyam me.
okay decimal ani loksel point ani loksel lakpane ko decimal pongi matungda zero sigi point matungda 1 points decimal point से 0 की मक्तले में से 1 के 2 की मरक से थमक पने digit ani right lom the move to idana ko adugi minus to thokibo 10 to the power 5 to the ko 17 ne mani minus 2 to thokaga 10 to the power 15 la pone yare ko okay then next second part sidi try to the rone second part we know that frequency later na tra adu regadi second put what is kari no what is wave number have ni yare ko adu regadi wave number ki formula do haning sing si wave number have ni na wave number se kya ga mana ki koi na wave number is equal to 1 by lambda have like ko because wave number or wave number is the inverse of wavelength high given aduna wave number is equal to mu bar is equal to 1 by wavelength that is lambda lambda is a wavelength gani ko adu we all already know that the value of lambda is 240 into 10 to the power 9 meter yare ko 240 into 10 to the power 9 minus 9 meter then substitute or my value say 1 divided by sigi value se puro substitute toro lambda ki value se ko adu ri kya ta gani क्या था रे
Sir, 4.16 into 10 to the power 6 tower.
4.16
into 10 to the power 6.
666 हाइन सुम चटपनेबो को लोइसलो 67 हाइन को 1.4.167 को यारे को into 10 to the power क्या आवा
6.
10 to the power
6.
6 okay 6 टाइम चुमे unity unity क्या तानी कई थमने unity बोस्नी का यूनिट क्या होएगा नी कई होएगा नी यूनिट से विकास
Sir, meter inverse nito.
मीटर इनवर्स होएगा नी को मीटर इनवर्स करीगिनो खमरा सिगी 240 into 10 to the power minus 9 meter है denominator दे लेबने बा यारे को अदुदी सिगी मथक दरी यूनिट याउदी को 1 खक्तनी लेइसे दुना मीटर से पुखलक को मथक denominator दगी numerator ओंखलक दगी inverse साइन लाको यारे को so wave number सु पुथोए को जे अदु हयिंग एग्जाम ददी याम नुंगारसि कनो पिरक्तुनेबा ऑप्शन पिरक्तुने ए हुजिक नोइददी क्वेश्चन जे ऑप्शन याउदबि दोइना पीबनेबा को हुजिक ओइनादि होटनबा यारे को हयिंग एग्जाम द ऑप्शन याउको मतमददी आइना ngarang nahan tawba mawong do answer pi bai mawong do ko adu maina khandok pa yaba sorokani chap manaba manaba sorokani ba yare ko chap yeng habet manaba khajik kitang dikhena deba ko adu matam dudana kitang section ba mo change adu hodok pada value do ama khaktang option da ama khaktang manaba yarogadi direct adu ki answer do chumena khanba yare yare ko adu noina lana hot khagadi value lana tarakti value lana tarakpudadi adu chumena haina coaching grade adu su lan dine dum ko so confidence amna leina hotpama chumna hotpama changi yare ko aduga matim tangare loiselase ngasigi ko sida toroga so next akon to this say electromagnetic spectrum have kaino what is electromagnetic spectrum akhoi the radiation mayam leiba ko electromagnetic radiation mayam lei radiation sing do sida lei to cosmic rays then gamma rays x-rays then uv ultraviolet have the kind of visible rays then IR infrared ray microwave radio wave ko atopa khara su lei maru ina si sing je ko FM gaina mayam lei ko na radio gi FM ga tawu ko adu akhoi hojik adu makti kana tawro sigi sing je dang yeng asi yeng sin medi ka ne te du su ko noina ko ray makhal si koi lei sigi ray makhal sing se if they are arranged in the increasing order of their wavelength or decreasing order of frequencies, then such arrangement is called electromagnetic spectrum. So the makha diagram yaw yeng si ko electromagnetic spectrum have se kari no have se yare ko si se ko na electromagnetic spectrum have the name yare ko electromagnetic spectrum okay sideo mathak is the wave playing le ko kitang zoom in toro no yeng mo tam de ko mathak wave playing le makha dana frequency le wave playing value sing se increasing order dani ahambra cosmic rays 10 to the power minus 18 ni then gamma rays 10 to the power minus 14 x-ray na magi wave playing value se 10 to the power minus 10 sigi mar side le iba ko aduga visible gi su sigi jaga se le ko visible gi na 40 nanometer dagina 700 nanometer fo sorry 400 nanometer dagina 700 nanometer yareko sometimes 800 power push yaw ya ko like ki kitang dikhe na gani author khe na ma tungina ko but generally 400 nanometer dagina 700 nanometer po se visible gi wavelength gi range ne visible rays kara bo diba wavelength dagana 400 nanometer dagina 700 nanometer smile to dina arrange store in the increasing order of their wavelength radiation sing je ko aduga last wavelength khwaidagi yamba radiation se kanano hamatam the radio wave 5 10 to the power 2 attention minus lo yawi ko sisina yawde similarly frequency the arrange to matam dana hujiki order to kaisu kaide adum same sequence adum lai to whatever decreasing order of their frequency oi wavelength of frequency ga se inverse oi na bai tare aidi magi chatpagi mong se ko value de inverse oi have dina te ko adu frequency se cosmic tagi radio wave fok chatpa matam da decrease tawre first the cosmic ray ki value se 10 to the power 26 ni then gamma ray ro kon tam 10 to the power 22 x-ray the 10 to the power 18 and sum tam na decrease tawre finally radio wave the 10 to the power 6 khak tani ladies yareko so from this ko si table se phawam change visible spectrum da kari light ya kari color yawi bibgyor yawi na tra bibgyor se ko rainbow do river 7 colors to ne order sequence na ina khamam change karamana wavelength khwaida yami ade karamana khwaida gi wavelength nemi frequency kana yam yamano ade karamana frequency lowest frequency leibano among the visible spectrum adegi or among the radiations which cosmic x-ray gamma hari mayam sigi manung ko then sequence maru oi sigi sequence ko cosmic gamma x-ray infrared have a sequence na ina khangmam chu change sidagi koina question kara hangdo hangjin to we yareko hujiki arrangement dubune koina electromagnetic spectrum haina kois yareko the decreasing order of frequency and frequency kakta hareko increasing order of or increasing order of wavelength ni hairasu ko wavelength yareko sida arrange to buni and hairasu yare yareko sigi order sima phabam change hayeng noida ray ani hum pire khalo gamma then microwave visible ahum je pire khalo aduga moigi increasing order of wavelength the arrange to and hairagani so kari khang da yaro koi sequence khang da yaro the option is my question is my hello the correct sequence of electromagnetic radiations are is haraga option A option B option D hana pirak tuni adai da achumba sequence to karamano khanma mu changi yare ko adugi marakta huje akoina hiyeng ke the cosmic rays has the highest frequency or lowest wavelength hujita hagi duni radio waves na highest wavelength leba du lowest frequency leba radiation ni yare ko so last question simadi try to ro yum da ko noina hot podo engon da kenoin tharo ke tare photo tharo engon hot pe yare ko last question sim try to ro du engon da forward to slo so thank you very much gyan da ba yawra sibok da